The topic for today's presentation is solenoid valve localization, feasibility and cost optimization. It is done by us, A. Ashwin Chitra and R. Rohini of Vale Tech College. We undertook a project in WAPCO India Limited. Air magnetic solenoid valves, they are specifically used in air braking in heavy vehicles. The whole purpose of using a solenoid valve is to reduce the distance between the braking and the distance of stopping. The coil is traditionally made up of copper and the cost of importing the coil is very high. So our project was to localize the coil and provide a cost-effective solution for optimization. So the scope of our project is understanding the existing design, checking the compatibility of supplier designs and client requirements, analyzing the standards, proposal for localization with cost-effective solution. A solenoid valve designed to allow the passage of air or fluid through a chamber and govern the strength of its flow. It has the following parts: a bobbin, a coil, core tube, plunger and plunger spring. So this is a basic diagram. A molded coil. Within this is the copper winded coil. This is the core tube, the plunger, supply and the inlet and outlet. Now the basic operation is, now when this coil is energized, it attracts this plunger through this path. This plunger seals a hole. This hole seals the gap between the inlet and the outlet. So there is a continuous air supply, and when the coil is energized, the plunger gets attracted and air flows from the inlet to the outlet. But when the coil is de-energized, the plunger returns back to its original position, closes the opening and the air passes from the delivery tube to the exhaust. This is the practical view of the coil. All these parts are sealed within, and the delivery end of the coil is attached to a piston. This piston, when the coil is energized, attracts the plunger, and there is a flow of air from the inlet to the outlet. The outlet air that comes from the solenoid valve pushes the piston out. This piston hits the wheel of heavy vehicles and brake is applied. So this is the process that takes place.
Let's now see the overview of the process. Firstly, the process of estimating the feasibility of an imported solenoid valve, that is the ABS solenoid valve, for manufacturing is locally along with providing a solution for cost reduction in solenoid valves was undertaken. Secondly, a sample was given to understand the design of ABS solenoid valve, and the coil was dismantled to understand the design, and the materials used for the coil on the whole was analyzed. As a solution for the cost reduction, the copper windings material was replaced with aluminum. But implementing this in ABS coil would take a time period of more than 6 months. Therefore, a locally manufactured air magnetic solenoid was taken to make the implementation process easier. The wire used was a super enameled aluminum wire with polyamide amide coating. The wire was wound and molded similar to a copper wound solenoid valve. After a complete assembly, it was sent through a series of performance tests. Once the preliminary tests were undertaken, the coil was sent for endurance testing. Let's now see about ABS coil. Anti-lock braking system is an automobile safe system that allows the wheels on a motor vehicle to maintain tractive contact with the road surface according to the driver inputs while braking, preventing the wheels from locking up and avoiding controlled skidding. ABS generally offers improved vehicle control and decreases stopping distance on dry and slippery surfaces. This is the vehicle that does not have ABS system. This is the process which has ABS system. Let's now see about localization of ABS coil. Anti-lock braking solenoid valve is used in anti-lock braking system to prevent the wheels from locking. ABS valve is a type of 2x2 solenoid valve. ABS valve has two coils assembly, which we can see in the diagram, which are connected in anti-parallel connection. This is the process of dismantling. This is the overview of ABS solenoid valve. which has two bobbin. One is white bobbin, another is red bobbin, and this is the outer mold, which the outer mold is removed using lathe tools. We can see the supporting plate here. Two colors of bobbin were used. That is one red. It is made up of Freinet 530 FR. Another was white PPS and was made up of PPS. This is the circuit diagram of the 3-pin supply. One is from the red bobbin, another is from the white bobbin, and the another supply pin is interconnection between two bobbins. This is the bill of material of a ABS solenoid valve, which contains core tube, white bobbin, red bobbin, winding, supporting plate, connector, supply pins, moulding and contact plate. This is the electrical specification of the valves. This is the suggested modification, that is the changing the winding material from copper to aluminum for cost optimization. Here we can see the some of advantages of copper wiring. That is, copper has highest electrical conductivity. It has high strength resistance stretching. Copper does not lose its connections. It has low coefficient of thermal expansion for an electrical conducting material. A unique combination of high strength and high ductility makes copper ideal for wiring systems. Some of the disadvantages are copper wiring is costlier and it has heavier mass. Some of the advantages of aluminum wiring: it is cost effective, has lighter mass, higher heat transfer rate compared to copper. This is the disadvantages of aluminum wiring. Aluminum oxide is not an electrical conductor but rather an electrical insulator. This is the copper versus aluminum wire. Some of the comparisons: that is, the heat thermal conductivity or heat transfer rate of copper is 92% versus aluminum, which is approximately 49%. This is the basic property. For the purpose of easy implementation, a local air magnetic solenoid valve was also taken as the ABS coil. Air magnetic solenoid valve. Specification of air magnetic solenoid valve. These are the modification process that we have taken. This is the SW chart, which is used in Indian wire manufacturers. Some of the formulas involved for calculation of parameters. These are the some of the parameters which are calculated. For copper 37, aluminum 34 and aluminum 35 are chosen. For copper 33, aluminum 30 is chosen, and for copper 34, aluminum 31 is chosen.
So these are the testing procedures. The basic purpose of using aluminum wire is for cost reduction, but the major disadvantage is that it doesn't have high endurance. So a number of testings has to be done to ensure that the coil will work properly. So first one is an aluminum wire test, a heat shock test. The wire is heated for 30 minutes at 200 degrees Celsius and the enamel coating is checked. And then actually this is the air magnetic cylinder. So when the coil is energized, the piston has to move out, and when the coil is de-energized, the air has to come through the exhaust valve. So this is done in the performance test. So on leak is when the coil is energized, the air should come through the outlet port, and off leak is when the coil is de-energized, the air should come through the exhaust port. So these are the test results. And endurance testing. The coil should withstand severe working conditions, so it is heated continuously for 6 hours. And the performance of the coil is tested. The resistance should be within 175 ohm. So this is a duty cycle test. The graph that we have obtained, it has to have a 100% duty cycle. This is a variation of force with respect to voltage. The coil gets picked up at this particular voltage, so you can see a peak there. So these are some of the photos of our testing rigs. So this is a cost calculation. The basic purpose of changing copper to aluminum is the cost reduction. So this is a cost reduction that we have shown. A graph for the cost. The cost of copper per product is 14.621, whereas for aluminum it would be only 2.8. So per product, only in winding we save about 11.7. An industry that uses more than 40,000 coils, the overall cost saving would be 1.48 crores. Thank you. These are references.
Thank you.